I would like to discuss about hydrostatic force on plane surface. So, according to this title, you may know that we are going to discuss about force that occur due to the existence of liquid. So normally we will use water here, and in static condition means there are no velocity or the liquid is remain in the container. And then when we have a pressure here from due to the existence of liquid here, so it will act on area which is on the plane surface here, and then it could create force. The existence of fluid causes pressure. This pressure acts on surface to produce force. This force is known as hydrostatic force. For example, we have a container like this, so and then we fill with a liquid here, so and then we let this liquid act to the atmospheric pressure. So we are dealing with pressure gauge pressure, so we assume that PATM here is equal to 0. So when the pressure is 0 means there are no force. So and then we could draw force distribution on the vertical plane here and vertical wall here as this one. So the force will become bigger and bigger, and maximum pressure will occur at the bottom here, then it will create a maximum force. So and then you could draw the force distribution like this one. So and then if you want to draw a force distribution on the horizontal surface here, we believe that the pressure that occur on this surface is constant because the water depth here is constant. So we could draw the force distribution like this one. So means that the arrow here will remain constant. Hydrostatic force is a force that produced from static fluid. However, in gauge pressure, atmospheric pressure is 0. Then the force produced by the existence of atmospheric pressure is 0. In this chapter, we are focusing the force that produced by the liquid, especially water. Pressure that acts on the bottom surface is constant because the depth of the liquid is constant. So, the force that acts on the bottom surface can be calculated by using the following equation. So, because we have a lot of force here, a lot of forces here, we assume that this total force can be illustrated as a resultant force, and it will act on a single point on the centroid of the horizontal plane here. The effective force, also known as a resultant force, Fr, can be indicated by using an arrow as shown in the figure. The effective location of the resultant force Fr is at the centroid of the bottom of the surface. This is valid only for constant pressure that acts on the flat and horizontal surface. Pressure also acts on the vertical surface of the tank. The pressure distribution is not constant. Pressure on the liquid surface is 0, while pressure at the bottom is the highest one. To calculate the resultant force Fr, the equation is still the same, but we need to determine the effective pressure that make effect on the vertical surface. We cannot just pick one pressure value and multiply it with the area. It is a totally wrong method. The simplest way to determine the effective pressure that occur on the vertical surface is by rearrange the pressure distribution itself. Here in this diagram, we found that the pressure distribution is in triangular shape here, where the lowest point here will give us the highest pressure. So, and then if we cut this area and then we transfer this area into this area, we could get a constant or a rectangular shape of pressure distribution. So this will ease our calculation of force, because we could use this amount of pressure, because all pressure that act on this point is constant. So we just take one pressure here, and then we could multiply with the area. So, and then we could get the force. Okay, so and then we could say that the pressure at point 3 here, after we take this area into this one, so it is P3 can be write as P3 is half of P2. And then P2 here can be calculated by using the equation of rho, G, and H. And then to make it half, actually we reduce the height of this one. So we could write as 1 over 2 rho, G, and H, because we cannot change the value of rho G here, because the density of water and the gravity acceleration is constant all the time. From figure, we could conclude that resultant force Fr that acts on the vertical surface can be determined by using this equation. By using triangular pressure distribution, we could write Fr is equal to 1 over 2 rho GH times HW. So HW here is the area. So the H is the height of the water, and W is the width of the tank, or the width of the water here. So and then rho and G, rho is the density of fluid, G is the gravity acceleration. If we reconstruct the triangular pressure distribution into rectangular pressure distribution, the conservation of area is satisfied. Resultant force Fr can be written as this one. So, and then as I said previously, the 1 over 2 here is actually belong to the height of water, because we cannot change the value of rho and gravity. So, and then we could simplify or officialize the equation become rho GHCA, where the HC here is the distance from the free surface. So we have a free surface here until to the centroid of the vertical surface. Okay, I hope students could remember this equation, because in this chapter you need to calculate the rho GHCA to get the resultant force on plane surface. Thus, the magnitude of the hydrostatic force on plane surface can be calculated using this equation, rho GHCA, where HC here is the vertical distance, the depth, from the free surface to the centroid of the submerged plane. So, and then the A here is the area of the plane surface that contact with the liquid. So normally in this syllabus, we will use water as our liquid, as our fluid. The hydrostatic force is act from liquid to the plane surface. This force is pushing the wall outward. So means that if you want to draw a free body diagram, you need to draw the force is from water going outward like this. So, and then the resultant force need to be drawn perpendicular to the surface. So means that if the surface is inclined like this, so you need to draw the arrow is like this. So if the plane is vertical like this, so you need to draw the arrow is like this. And if let's say that we have a water here, and then the wall is inclined like this one, so you need to draw the force is like this. So please make sure that you draw the arrow to show the resultant force is perpendicular to the surface. The location where the resultant force Fr acts is not on the centroid of the submerged plane surface. It acts a little bit below the centroid. So please remember this fact. So means that previously we calculate the magnitude of the resultant force by using this equation. Then because force is a vector, so we need to determine the magnitude and also the location. So the location of the Fr is a little bit below the centroid. So for example, we have a plane here. So this is the centroid of the plane. So please do not draw the resultant force here act on the centroid. This is totally wrong idea. So you need to draw the resultant force here a little bit lower from the centroid here, because the idea of the centroid for the idea of the location of the resultant force here is to balance the force on at the bottom here with the force at the top here. So means that if we take the location of resultant force right on the centroid here, so the total force at the top is not equal to the force at the bottom here. So we need to balance the location. So the location is a little bit below the centroid. Then the location of Fr can be determined by using this equation. So please remember this equation to determine the location of Fr. So the location of Fr here will be shown in terms of y-axis. So we write as yr. So the equation will become yr equal I over yc times a plus yc, where the yr here is the distance from free surface to the Fr along the y-axis. And y-axis is always parallel with the plane surface. Yc here is the distance from free surface to the centroid of the submerged plane along the y-axis. And then please bear in mind that y-axis here will always parallel with the plane surface. And then A here is the submerged area of the plane surface. Please be careful about the design of the plane surface. It may be vertical or inclined at certain angle. If the plane surface stay vertical like this, y-axis is parallel with h-axis. However, if the plane surface stay inclined like this one, y-axis is parallel with the inclined surface. So means you need to draw the y-axis here parallel with the surface of your plane, while the h-axis is remain vertical, because the h-axis here is actually to calculate the pressure. So we know that pressure is equal to rho gh. So mean this h must be vertical, because pressure only affected by the depth of water.